Good morning, guys. I've created a rack and pinion system for a gripper that we created that can slide in and out with the rack and pinion. The problem that I have is that this bracket here in front of us is not big enough for this rack and pinion system, so we are going to have to create a new one. Okay, great, guys. We are going to create a bracket for the hex motor on our rack and pinion system. So the first thing I want to do is get this thing out of the way, and then we're going to start up FreeCAD, because that's the software in which I create all my stuff for the robots that we are using for first stack challenge. Okay, so I'll start with a new document, create the body, create a sketch on the body and the XY plane. Okay, that's what we are going to do. So I'll move this a little bit. This is our origin point, for those of you who don't know. And I'm going to start with a rectangular shape like this, roughly about the size as the brackets that is provided within the Tech Challenge set. So the width is about 4 centimeters, 40 millimeters, and this is where the difference comes in. The length is a little bit longer because our bracket is shorter than the one that the one that is in the box is shorter than this one that I wanted to create, to make sure that the rack and pinion fit. So this will be the first and the start of it. So 40 by 60, and we are going to let's close this, let's pad it. Normally when I do this, I'll pad it around about 4 millimeters. Okay, and then on this plane I'll click and I'll create a sketch on this plane. So if you have created anything for the Tech Challenge robots yet, you will know that the extrusions is 15 by 15 centimeters, millimeters. So basically halfway there is where the slot is of the extrusion. Okay, so I'm going to do this. I'm going to create 3 holes for nuts to fit in, to connect it to the extrusions like this, and I will right click to get out of the creation tool. So first of all, I'm going to set the distance for this one to 10 millimeters, and then I'll just paste them. So that one from there to there, you can see 20, and I'll move them up, and from there to there we'll set it at 30. That will give us the distance that we need. Now the height is halfway of the width of the extrusion, which would be 7.5 millimeters. So we'll set it like 7.5 millimeters for each one of these. Let's just do it again, from there to there, 7.5. And from there to there, 7.5. We've got the height right. Now I tend to do this, select the 3 circles and equal them so they're the same size, and then I'll set the size of the circle to 2 millimeters on the radius, which means it's 4 millimeters. It's a little bit bigger than it should be, but if you made a mistake and you didn't get your measurements quite right, it gives you a little bit of leniency, else you're going to waste a lot of space or a lot of filament creating things, and then it doesn't work, which will be time consuming and wasteful. So next in line, what we need to do is create the bracket or the fittings for the motor itself. Now this is supposed to fit to the extrusion, so from here upwards you're going to look at the measurement of roughly 20, 25, 26. Let's see, I'm going to create a hole there, and then from here up to there I'm going to set it to 27, would be just fine. And remember, if you create this, you always have to create or constrain it both ways, vertical and horizontal, on a 20 millimeter line. And we'll set this one again to the same side as one of these, and we just equal it. Now those are equal. So the next thing is the distance between this hole and the top hole where you connect the nuts for the motor is normally 17 millimeters. So I'm going this way. I'm going to add another hole like there, and from here to there I'm going to set it to 17 millimeters. That's pretty much about how far it should be apart. Again, I'm setting this to this equal. Normally it will give me what I need, a little bit of leniency. If I made a mistake somewhere, it won't be the end of the world. So there we go. Now all of these are already constrained. You can see it's fully constrained there. So the next thing I'm going to do is create a big hole for the axle to go through. And I'm going to put it in between here, and it should be straight in the middle. So I'll just create it. It should be 5. So let's make the size of it 5. That's for your bearings, your nylon bearings to fit in. And I'm going to put that again on a 20 millimeter line. That's an easy way to create the thing. And now I'm going to set the distance from here to there, because this is a fixed point. So from here to there I'm going to set the distance to 8,5. Smack in the middle between this circle and that circle. It should work just fine. Now we've got all the holes that we need for this thing, so we can close it. If it's fully constrained like that, we close it, and then we'll put the hole through it like that. Now we've got a plate, a bracket plate for the motor. The motor fit here. These holes are to connect the plate to the extrusions. And if you want to, you can do one more thing. Oops, cancel. I click on that. Let's create a little bit more. And what we are going to do is, just to make the thing a little bit more stable, I'm going to create 2 small blocks on each side like this. Okay, so from this point up to this point, the height would be 6,5, because the distance to the middle here is 7,5, but this thing is going to be 2 millimeters. So you're going from 6,5 to 8,5. That's what we're going to do. So that distance is 2 millimeters, and we'll do the same with this one. That distance, oops, that distance is 2. That just the slots in, it makes it so much more stable if you do it like that. So from here to there, the height would be 6,5 again, and that is set. And the distance from here to there, I've done this 1,6. let's see, I haven't done that one yet, so I'm going to set that distance to 38, and I'm going to set the distance from here to there, from this side to, okay, let's just do this, from there to there, distance 2 millimeters, okay, that's fine. Now we've got 2 millimeters to each side, which is fine. From that side to that side, and now we set the length of this thing. We'll make it 5 more. No, it's going to be too long. So I want to change that to 4. because the head of the nuts will fit there, and we don't want to make it too close to that hole, then it's going to mess up everything for us. So length there 4, that should be fine. It is fully constrained again, it should work for us. Fully constrained, close, and we extrude it 2 millimeters high. So we'll just go down to 2 millimeters like that. So, okie dokie, there you go. Now this is what the plate looks like at the moment, so let's do one more thing with the plate. I'm going to turn it a little bit so I can select that one, press Ctrl to select that one also, and then I'm going to chamfer it a little bit to just make the thing look a little bit better like that. Okay, that gives us the design that we want. This is the plate that we designed for our axe motor to fit on a rack and pinion. Okay guys, so this is the result after the print. As you can see, it fit beautifully on this rack and pinion set. So thank you for watching this video. I hope you enjoyed it.